So the big picture for this lesson is row operations and augmented matrices. So an augmented matrix is used for a system of equations. So let me do a simple system of equations here. Okay, so what I'm going to do is I'm going to write this in matrix form. That's the coefficient matrix. Variable matrix there. And there's the constant matrix. So an augmented matrix is kind of a simplified version of this. What you do is you take the coefficient matrix and the constant matrix and kind of combine that together. And usually you draw a little bar down there, and there are your matrix brackets. Okay, this is an augmented matrix. And so what you can do is you can use this to represent the exact same situation as the system of equations up here. And the augmented matrix is nice because it's easier to perform row operations to simplify the matrix and then solve the system. So the row operations, you can interchange two rows. So I could switch the first and second rows here if I wanted to, and it wouldn't change the value of the matrix. Another row operation is I can multiply one of the rows by a non-zero constant. In other words, if I wanted to multiply this second row by, say, -2 or something like that, I could multiply each of these entries by -2 and it wouldn't change the value of the matrix. Third row operation is adding a multiple of one row to another row, and that's like linear combinations to simplify the matrix. So I could multiply row 1 by -1/2, and then I could add it to the second matrix, and that wouldn't change the value of the matrix. So what you're going to be doing is you're going to be writing systems of equations as augmented matrices, and then using row operations to solve them. That's the big picture of this lesson.